so we decided to use them. There is one more subtle point here, and that's that we need to be really careful about marking segments as non-translatable. Because if our algorithm says, you don't need to translate this, the project manager might skip all these non-translatable segments in the translation step, and then maybe, you know, 1 or 2 days before the deadline where you're supposed to deliver the projects, you would find that there are hundreds of segments that you haven't translated because we said it's non-translatable. So we have to be really careful about this type of error. And also, each language pair is different. So it may look like some of these rules are universal, but really we found that for each language pair, it's best to train a separate model. And this is just a very simple chart which illustrates that if we use just simple rules to identify these non-translatable segments, depending on the language pair, we may get something like 5 up to maybe 15% of the coverage. And you can see that really this is the proportion of non-translatables in the data. So 10 to 15% are identified as non-translatable even with rules. So this is a useful feature because there's actually a lot of segments like this in the data. And with the machine learning or AI, we can usually roughly double the number of segments that we discover. We got a lot of user feedback because this was the first sort of machine learning powered features that we developed. And the general feedback was quite positive. People were happy about the savings and being able to understand the document before translation and allow maybe to offer a more competitive price. But users also struggled to adopt this feature. They complained about inconsistency, which occasionally happens. This is very true for neural networks, where even as a developer of the network, you may not be able to explain each individual decision. So segments or sentences which look very similar, and a human would say, if these 4 are non-translatable, then surely this similar one is also non-translatable. Well, the network doesn't think like that necessarily. So it makes surprising decisions when you look at it from a human perspective. And this, initially users found this quite troubling. And also there is some occasional false positives in the data where we say it's a non-translatable, but in reality it isn't. And users complained about this a lot. But interestingly, if you look at the statistics, we found, based on the usage data, that our machine learning-based NT detection is actually several times more accurate than the rule-based solution that people used previously. So it's interesting to see that even though the rule-based solution didn't really work that well, people could predict what it's going to do, and they understood the errors that it makes. Whereas the AI, even though it's several times more accurate, sometimes it's sort of opaque. It's hard to figure out why it makes these decisions. And so there's a big issue, I think, overall with machine learning in any application, with building user trust. Okay, so I guess that's enough for the non-translatables, and now to something more exciting, perhaps. And this is, I want to talk about the role of machine translation as we see it in Memsource. And so the natural question you might ask these days is whether machine translation is actually replacing humans. And there are a few exciting results from the NP research community to back this up. For example, we saw a paper, very sort of influential and really covered in the media, from Microsoft Research, where they claimed human parity in English-Chinese news translation. And this paper was really well sort of methodologically carried out. And it caused a lot of stir, I think, across the world. But also, I'm very happy that also my home university had a result that is quite nice and similar to this, even though I had nothing to do with it. That's that they developed for an annual competition in machine translation that's held every year by academics, a system that when you blindly evaluated their machine translation system, you found that it was actually people, the annotators who evaluated the system, liked its outputs better than the reference human translations that were provided in this mix for control. And take this result with a big grain of salt, because the evaluation is based on the level of sentences. So the translators, they have to decide when they see just a single output of machine translation and a single input sentence. whether this translation is good, and this translation maybe is better, but without the context, you cannot really differentiate a lot of the issues that can be problematic. And maybe the humans did it correctly, and the machine translation has them wrong, but you cannot simply tell that from just looking on the single sentence. It's, I think, without discussion that translators are and will be essentially indispensable in for many years to come. And from a perspective of a machine translation researcher, I could say that machine translation struggles with things like coherence, terminology, style, and as a researcher I might try to formulate this in some mathematical way and then propose models that solve this problem somehow better. But I think the crucial point really is that as a translator you are responsible. You have to make sure that you convey the correct meaning from the source to your translation. You have to account for ambiguity both in the source and in your translation. You have to be very careful with choice of wording. You have to preserve the emphasis that was there in the original text. You have to make sure that it's completely clear to understand. You should convey the original intent of the text as well. So imagine machine translation translating something like an international marketing campaign. That can be either a complete international embarrassment or a really big success that helps a company expand to some new country. But you as a translator have all the human knowledge to make sure that you carefully craft the translation in such a way that it will do it. The machine, it doesn't have that capability. Similarly, imagine translating a 20-page legal document. You really have to make sure that you're consistently referring to all the involved parties correctly, consistently with the same name, and that you don't, for example, flip the meaning of some sentence, which machine translation likes to do. So I think we are still quite a long way from empty, at all replacing any human translation. But let's go ahead, and of course machine translation is useful. So it's actually the most obvious machine learning based feature that we have in the industry. And typically what people do is this post-editing scenario where the translator gets machine translation output and they just change it so that it's passable, acceptable as the final translation. And these days we know that the neural machine translation can really produce good quality outputs. I mean, I just talked about achieving human parity on the sentence level. But there is a conventional wisdom in the industry, and that is that, yes, these NMT outputs are typically much more fluent and grammatical, and really as a former MT researcher, I'm extremely happy to see that it got so far without any contribution of me, but anyway, it's good to know. And, but they really can contain very serious errors. But because the machine translation is so fluent and so grammatical, you look at the sentence and you see nothing wrong. So it's the cognitive load for the translator could actually be higher now with the better MD, because you need to be much more careful checking that it says exactly what the source sentence was saying. That brings the question, does even this really much better MD save time at all? And I think I'll show very soon a chart that conclusively says yes it does. But it really depends on the quality of the sentence that you're working with. And I would like to stress that still outputs which require no changes at all from the humans are quite rare. I think it's like 5 to 10% of the time. And so this chart, hopefully it's visible, shows a relation between two magnitudes. So on the x-axis, what we have is some measure of similarity between the machine translation that you got as a translator and the final output, the final translation that you produced. And on the y-axis, we plot the speed with which you can create the translation. And so if you look here, for example, on where the similarity is 90%, we can see that the translator is more than twice as fast, just post-editing, these remaining 10% of the sentence, than producing a sentence which only has like 50% similarity to the final translation. And so I think this illustrates really 2 points. MD is very useful for translator productivity, but also it really requires that you post-edit that focus on high-quality MT. So there is the problem that people face when post-editing, and that's that you have to go through lots of low-quality machine translation outputs just to find the small, relatively small percentage of cases where machine translation will be helpful to you as a translator. And this problem has, I mean, the community has been aware of this, of course, for ages, so I'm not saying anything new now, but this leads to a task, a machine learning task, called machine translation quality estimation. And it's a well-studied problem. People have been working on this for years. There are even academic shared tasks where people compete in trying to develop the best QE system. And the general setting is that you're sort of like a prophet or like an oracle. You get a source sentence and the machine translation output, and you're supposed to predict how much change it will require. This is, of course, a very difficult task, and the academic task is very sort of generally defined, which makes it even more difficult. We try to focus on a more simple setting. We don't try to estimate, for example, whether each word in the MT is correct or not, but we just look at the whole sentence and we try to say, is it great, is it good, you know, maybe is it usable, or is it just a bad MT? For the first version that we developed so far, we have these categories, the three categories: perfect machine translation, then something that requires very, very few post-edits, near perfect, and simply everything else, because it was just the simplest thing to start with.